Hey everyone, this video will be part 1 of factorizing quadratic expressions, as we're only going to cover how to factorize quadratic expressions in the form of ax squared plus bx plus c when the value of a is equal to 1. We will cover how to solve quadratic equations using the 3 different methods in another video, but to be clear, you cannot factorize all quadratic equations to solve them. There's one main thing you need to watch out for when factorizing quadratic expression, and that is the signs. Take a look at this example. X squared plus 6x plus 9. So to factorize this, we need two numbers that multiply to make the value of c, which is positive 9 in this case, and add to make b. So we need two numbers that add to make 6 and multiply to make 9, and both have to be positive. This is relatively straightforward, as positive 3 would be the answer. To write out the factorized form, we will open two sets of brackets, put x in each of them, and add 3. This could be further simplified to x plus 3 squared, as x plus 3 times x plus 3 is like saying any number multiplied by itself squared, so it would be x plus 3 squared. Let's try a different example. X squared minus 8x plus 7. If we list all factors of 7, we will get minus 7, minus 1, 1, and 7. Now the value of b is negative, and the value of c is positive, so from that, we know that the numbers in the brackets have to be two negatives. As two negatives multiplied by each other will give a positive value, and when they're added together, you get a negative value. We know that we cannot use the positive factors of 7, so our factorized form will inevitably be x minus 7 times x minus 1, and you can check your answer by expanding the brackets again, and you will get x squared minus x minus 7x plus 7, which then simplifies to x squared minus 8x plus 7, and you got the correct answer. Let's have a third example. X squared plus 4x minus 5. The factors of minus 5 are minus 1, 5, 1, and minus 5. We need a combination of those that add up to positive 4, so we need a greater positive value than the negative, which means we will need positive 5 and minus 1. And our factorized form will be x plus 5 times x minus 1. There are two cases that do not require following these steps that we mentioned previously, when you don't have a c term and the difference of two squares. When you don't have a c term, like when you only get, say, x squared plus 6x, you can only factorize x out of the expression and get x times x plus 6. The difference of two squares, however, is when you have two square values subtracted from each other, like x squared minus 9 or 16 minus x squared. In cases like this, you put the square roots of the two numbers in two brackets, once added to each other and once subtracted, as the b terms cancel out each other when expanded. For example, x squared minus 9 would be x plus 3 times x minus 3, as when expanded you will get x squared plus 3x minus 3x minus 9, which then simplifies down to x squared minus 9. And that's all for this video. Please do leave any suggestions, corrections, and questions in the comments section. And until next time, thanks for watching and see you in the next video.